Solve problem 1.34 charged objects. Consider four charges placed at the corners of a square with side length 1.25 meters as shown in the figure 1.23a. What are the magnitude and the direction of the electrostatic force on Q4 resulting from the other three charges? Yeah. So we have four charges here. Three positive charges, Q1 1.5 microcoulomb, Q2 2.5 microcoulomb, and Q4 4.5 microcoulomb. And we have a negative charge Q3 minus 3.5 microcoulomb. All these charges are placed at the corners of a square with side length of 1.25 meters. So the question is to find the total electrostatic force on Q4. Yes, okay, we have multiple charges here, so they would exert force on each other. So we are going to find the total force exerted by Q1, Q2, and Q3 on Q4. Okay, so I'm going to write that down. Force, we're going to find net force on charge number 4. So that will be the force exerted by Q1 on Q4 plus force exerted by Q2 on Q4 plus force exerted by Q3 on Q4. It's a two-dimensional problem. We have x-axis and y-axis. X-axis, y-axis here. So it's a two-dimensional problem. So we are going to deal with vectors, right? So these are all vectors, right? Yeah. So we are going to find F1 to 4, F2 to 4, and F3 to 4. Then add them to find the net force on 4. All right. So let's find the magnitude of F1 to 4, 2 to 4, and 3 to 4. Yeah. So F1 to 4. Recall Coulomb's law. Coulomb's law, electrostatic force is equal to K Q1 Q2 absolute values over R square. K is a constant, Coulomb's constant, 9 times 10 to the power of 9 Newton meter square per Coulomb square. That is K. Q1 is charge number 1, Q2 is charge number 2, R is the distance between Q1 and Q2. Yes, so F1 to 4 is equal to, we are talking about Q1 and Q4, right? So how do we focus here? Focus here. We're going to focus here, right? So we have two charges, Q1 and Q4. The force exerted by 1 on 4 will be equal to K Q1 Q4 over distance between 1 and 4. Distance between 1 and 4, I'm going to call it R14. Okay, distance between Q2 and Q4, I'm going to call it R24. Distance between Q3 and Q4, we'll call it R34. Yeah. So distance between Q1 and Q4 is R14 squared. Okay, let's substitute the values. K is 9 times 10 to the power of 9. Q1 is 1.5 microcoulomb. Micro, you have to convert it. Micro is 10 to the power of minus 6 coulombs. So 1.5 times 10 to the power of minus 6 coulombs times Q4 is 4.5 times 10 to the power of minus 6 divided by the distance between them. It's a square, so all the sides are equal, 1.25 meters. Okay, if you solve it in the calculator, you'll get, let me check, 9 times 10 to the power of 9 times 1.5 times 10 to the power minus 6 times 4.5 times 10 to the power of minus 6 over 1.25 squared. Yeah, this is squared, right? Yeah. Okay, so the answer is 0.03888 meters. Let's round it off to 0.039 meters. Okay. Yeah, so that's sorry, it's not the unit is Newton. Sorry, it's not meter. You find a force, right? Unit of force is newtons, 0.039 newtons. Right. Let's find F2 to 4 now. Magnitude of F2 to 4. So F2 to 4. F2 to 4 will be, how do you write the equation? Okay. Now we have two charges. Focus here, 2 and 4. Focus right here, 2 and 4. Okay. Q2 2.5 and Q4 4.5. So let's write the equation. Okay, Q2, Q4 over, what is the distance between them? R24, right? R24 squared. Okay, substitute the values. 9 times 10 to the power of 9. Q2 is 2.5. 2.5 times 10 to the power of minus 6. Q4 is 4.5 times 10 to the power of minus 6 over distance between them. This is a problem. R24 is not given, right? So let's find R24 first. Yeah. To find R24. R24. Yeah. So let's focus on this triangle here. Right triangle here. It's a square, right? Yeah. Let's focus on this triangle here. This triangle. Okay. Yeah. This side is 1.25 meters. 1.25 meters. This side is also 1.25 meters. We need to find R24, which is this side. So it's the hypotenuse, right? This is 90-degree angle. The side opposite to 90-degree angle is the hypotenuse. So let's use Pythagorean theorem. R24 equals square root of 1.25 square plus 1.25 square. Right. So if you do that, square root of 1.25 square plus 1.25 square, you'll get 1.7 meters. 1.767 meters. Let's round it off to 1.77 meters. Okay, so 1.77 square. Solve it in the calculator. 9 times 10 to the power of 9 times 2.5 times 10 to the power of minus 6 times 4.5 times 10 to the power of minus 6 over 1.77 squared. The answer is 0.032318 newtons. It's approximated to 0.032 newtons. Right. Now, the last one, F3 on 4. F3 on 4. Okay, let's write the equation. It's easy now, right? We have 3 and 4, charge 3 and charge 4. So okay, Q3 Q4 by R34 square. Yeah, Q3 is a negative charge, but here we are finding the magnitude of force. So just taking the I'm ignoring the negative sign here. So Q3 is 3.5, Q4 is 4.5. Distance between them is 1.25. It's a square, right? It's the side of a square. So 1.25 meters. So 3.5, 4.5. So 9 times 10 to the power of 9 times 3.5 times 10 to the power of minus 6 times 4.5 times 10 to the power of minus 6. Distance between them is 1.25 squared. Okay. 9 times 10 to the power of 9 times 3.5 times 10 to the power of minus 6 times 4.5 times 10 to the power of minus 6 over 1.25 squared. 0.09 0.09072, approximately to 0.091 newtons. Alright, so we have magnitudes of all the forces. Now let's find the direction of these forces. Okay, so I'll draw that picture again. Okay. So we have three positive charges. 1, 2, 3. 3 positive charges and 1 negative charge. We are going to find the total force exerted on Q4. This is Q4, right? Mark. This is Q1. This is Q2. This is Q3. This is Q4. So we are going to find the total force exerted on Q4. Right. So F1 to 4. Force exerted by charge 1 on charge 4. Okay, so both of them are positive charges. So Q1 will try to push Q4 away from it, right? Q1 will try to push Q4 away from it. So the direction of this force, FQ1 to 4, will be in this direction, right? Is Q1, this is F1 to 4. Because Q1 being positively charged will try to push Q4 away from it. So this is the direction of F1 to 4. Now what about Q2? Same thing, right? Q2 is also negatively charged, so Q2 will try to push Q4 away from it as well. So the direction of this force will be this direction, right? Yeah. F2 to 4. Q2 is also positively charged. It will try to push Q4 away from it because both of them are positively charged. That's why F2 to 4 is in this particular direction. What about Q3 to 4? Q3 is negatively charged, so Q3 will try to attract it. So Q3 will try to attract it. So this is the direction of F3 to 4. Okay, so now we have three different forces with three different magnitudes in three different directions. I'm going to draw all these forces together. So F1 to 4, F1 on 4 in this direction, F1 on 4, F2 on 4 in this direction, F2 on 4 in this direction, F3 on 4 is in this direction, F3 on 4, F3 on 4. Okay, so we have three vectors in three different directions. So to find the net force or the resultant vector, we will find the components of these vectors, then we will add x components together and y components together. Okay, before solving vectors, let's recall a bit about vectors. Let's say we have a vector like this. Okay, this is a vector. Yeah, it's a vector. Okay, how do you draw the components of these vectors? How do you draw the components of these vectors? It's very simple. Yeah, use a different color. Yeah, x component will be on x-axis. So this is the x component of this vector. Let's call this vector vector A. This vector A. So x component of this vector, which is ax, is in this direction, and y component of this vector is in this direction, ay. Okay, now how do you find these components? So this is how you draw the components of vector A, ax and ay. Now how do you find these components? To find the components, we need an angle as well, this angle or this angle, either one of these angles. Okay, let's say this angle is theta. Okay, there's a shortcut to find the components. So to find x component here, because x component is touching the angle, this is angle, right? X is touching the angle, so x component is vector A times cosine theta. Y component is not touching the angle, right? This is our angle, y component is not touching it. So y component is a vector A times sine theta. Alright, yeah. Let's do another one. So let's say we have another vector in this direction. Okay. Yeah, that's my vector. How do you draw the components here? Let's call this this vector vector B. How do you draw the components of this vector? Okay, x component will be on x-axis, but this time it's pointing to the left, or it's on negative x-axis, right? Yeah, that's my x component of this vector. What about y component? This one, right? This is by. Okay, now how do you find these vectors? Alright, so let's say this time I'll give you this angle. Okay, let's say this is our angle, right? Okay, I'm going to find the components. Bx bx is not touching the angle, right? This is our angle. Bx is not touching the angle, so bx is sine. Okay, if a component is not touching the angle, it's vector multiplied by sine of the angle, sine theta, b sine theta. Yeah. What about by then? By is equal to by is touching the angle, right? So b cosine theta. Yeah, but there's a problem here. Bx is on negative x-axis, right? So we should put a negative sign here, right? By is on positive x-axis, so no issues with by. Bx is on negative x-axis, so put a negative sign there. Now let's get back to the question. I'm gonna delete this. Yes. Okay. To solve this problem, I'm going to draw a table. Okay. Yeah. So. Right. Okay, x component here, x here, y here, x component here, y component here. So our first force is F1 to 4. Okay, F1 to 4, right? Okay, for F1, this is F1 to 4, right? How do you draw F1 to 4? This is F1 to 4. F1 to 4. F1 to 4 is on x-axis, on positive x-axis. So it has only x component. It has no y component. There's no way you could draw y component for this one, right? Y component is 0 for this one, for this vector, F1 to 4. So y component is 0. So x component will be just F1 to 4. You don't need to calculate it, okay? Yeah. So what is F1 to 4? 0.039 newtons, right? So F1 to 4 will be 0.039 newtons. 0.039. Okay, I didn't solve it because y component is 0. So the whole vector F1 to 4 is just the x component, 0.039. Now, what about F2 to 4? F2 to 4. Okay, F2 to 4. F2 on 4. All right, so I'll draw F2 on 4. F2 on 4. This is F2 on 4. This direction. F2 on 4. I'm going to draw x component and y component for this one, for this vector. So this is the x component. This is this vector is F1 to 4, so, right, sorry, 2 to 4, right? So this vector is the x component of F2 to 4. So F2 to 4 x. You can call it by any name, it's not a problem. Yeah, this is the y component of F2 to 4. F2 to 4 y, right? So we need to find these components, right? Okay, so to find these components we need an angle, right? We need an angle, or yeah, this angle, right? Either one of these angles, it's fine. Okay, I'm going to find this angle. I'm going to find this angle theta. Okay, let's call it theta. To find this angle, I'm going to draw another picture. Right. So this is our square, right? It's our square. Yeah. And our force F2 to 4 is in this direction, right? Yeah, that's my vector F2 to 4. And I'm going to draw components here. This is the x component, F2 to 4x. The same picture, F2 to 4x. And this is my y component, F2 to 4y. All right, we are going to find this angle, right? This angle is same as, okay, I'm going to draw a diagonal for this. Okay, diagonal for this square. So this angle theta is same as, sorry, this angle theta. Okay, how do you find this angle? Find this angle theta. It's simple. This side is 1.25 meters, right? This side is 1.25 meters again. And we found the length of this side, 1.7 or something, right? Yes, 1.77. So this side is 1.77. This is the hypotenuse, 1.77. Yeah. So to find this theta, you can use any one of the three trigonometric equations, trigonometric functions, cosine, sine, or tan. All right. So I'm going to use cosine here. Okay. You can use any one of them. It's fine. Okay. So cos theta is equal to adjacent side over hypotenuse. Okay. So cos theta equals, all right, so this is theta. So opposite of theta is opposite side. The side next to theta is adjacent side. This is 90-degree angle. Opposite of 90-degree angle is hypotenuse. All right. So which one is adjacent side? This one, which is 1.25. 1.25 divided by hypotenuse is 1.77. 1.77. All right. So cos theta is 1.25 by 1.77. What is 1.22? 1.25 divided by 1.77. It's 0.7. 0.706. All right. I'm going to find theta here. Theta equals cos inverse this answer, 0.706. 45 degrees. Okay. Yeah. So this angle is 45 degrees. This angle is also 45 degrees, or this angle is 45 degrees. Okay. Now let's find these components, f2 to 4x and f2 to 4y. How do we find f2 to 4x? f2 to 4x is equal to f2 to 4 cosine theta, because x component is touching theta, right? So it's cosine. What is f2 to 4? f2 to 4 is 0.032. 0.032 cos 45. 0.032 cos 45. 0.02267. So round it off to 0.023 newtons. Now what about f2 to 4y? Y component is not touching. Y component is, this is the y component, it's not touching the angle. So it's sine f2 to 4. f2 to 4 sine theta. 2 to 4 is 0.032 sine 45 degrees. 0.032 times sine 45. Same answer, 0.02267. Yeah, so round it off to 0.023 newtons. Right. Okay. Both these components are positive because this is on x-axis, this is on positive x-axis, this is on positive y-axis. So both of them are positive. Right. So 0.023. 0.023. Both the components are same, 0.023. Now the last vector. Last vector is f3 on 4. f3 on 4. f3 on 4. Okay. So which one is f3 on 4? f3 on 4 is this vector, f3 on 4, which is on negative y-axis. So it has no x component. It has only y component, which is same as f3 to 4, right? What is f3 to 4? f3 to 4 is 0.091 newtons. So x component is 0. There is no way you could draw x component for this one, right? So x component is 0. What about y component? Y component is same as f3 to 4. So F3 to 4 is 0.091. Yeah, but this vector is pointing downwards, so the y component is negative. Negative is 0.091. All right, now let's find the net force on Q4. Okay, so F net on 4. Add all the x components together and add all the y components together. So 0.039, adding x component, 0.039 plus 0.023 plus 0, you'll get 0.062. Add them all the x components together, this one plus this one plus this one, right? Yeah. Okay. So x component is 0.062. Now what about y component? 0.023 minus 0.091, which is minus 0.068. Minus 0.068. All right, so that's the net force vector, net force vector on Q4, right? Write this here, F net 4 is equal to, let's write this down in the vector, yeah, in the component form. F net force on Q4 is equal to 0.062, 0.062 x cap plus, that's the x component, right? So multiply with the unit vector on x-axis, which is x cap. Yeah, this is minus 0.068, minus 0.068. So plus into minus will be minus 0.068. That's the y component. So multiply with the unit vector on y-axis, which is y cap. All right, so that's our force vector. All right, let's find the magnitude of these vectors, of this vector F net 4. Magnitude of this vector. Magnitude is, all right, how do you find the magnitude of a vector? You use Pythagorean theorem. 0.062 square plus, the second one is negative 0.068. Make sure you put the component or the negative number inside the bracket when you take the square root. Okay, yeah. So the answer will be square root of 0.062 square plus minus 0. If you take the square of a negative number, you'll get the positive answer anyways. So you could either ignore the negative sign or just put it inside a bracket. Square. So this is the magnitude, 0.09221 newtons, approximated to 0.0, round it off, yeah, 0.092 newtons. That's the net force on charge number 4. Let's find the direction of this force as well. Direction. All right. So let's say alpha is the angle. We are finding the direction. How do you find the direction? So equation tan inverse y component over x component. So f for y over f for x. Y component over x component. So tan inverse is minus 0.068 divided by 0.062. Tan inverse minus 0.068 over 0.062 minus 47.64 degrees. What does that mean? That means we have 3 different forces, right? But the net force will be, I'll use a different color. Yeah, blue color. 47 degrees below the positive x-axis. Okay, this is the net force, the direction of the net force. Net force on 4, yeah, will be 47.64 degrees below the positive x-axis. Makes sense. We have three different forces. So the net force should be somewhere in between, or yeah, in between these vectors, right? Yeah, because F34 is negative, because Q3 is negatively charged. It will try to pull it downwards. And magnitude of Q3 is 3.5, which is quite high compared to other charges. So net force will be downwards. It makes sense. All right, so that's our answer. We found the net force, magnitude of net force, which is 0.092 newtons, and the angle or the direction of that force, that net force, which is minus 47.64 degrees. Yeah, that means 47.64 degrees below the positive x-axis.